Dr. P. Geeta, Associate Professor of Mathematics, V.V. Vanniyaperumal College for Women, Virudhunagar. Let us discuss about cosets, equivalent classes and how cosets forms an equivalent classes in group theory. We first define what is left coset. Let G be a group, H be a subgroup of G, let A be an element that belongs to G. Then the left coset of A with respect to H is defined as AH equal to A into small h such that H belongs to G. Similarly, the right coset of A in H can be represented by HA, which is equal to the set of all small HA such that H belongs to H. Next, we define congruence modulo class. A congruence B modulo H on G can be represented as A congruent B mod H if AB inverse belongs to H, if and only if AH equal to BH. Now, we are going to show that the congruence modulo H is an equivalent relation. It satisfies the condition of reflexive, symmetric, transitive. Then we say that this congruence modulo H forms an equivalent relation or equivalent class. Now only we define A congruent to B mod H if AB inverse belongs to H, if and only if AH equal to BH. From this, we already know the definition of the left coset, that is AH equal to A into small h such that A belongs to H. So we say that each left coset AH is the equivalent class of A under this relation, that is denoted by AH equal to equivalent class of A. So the same result holds for right cosets of H in G. So both right and left cosets of H in G are equivalent classes under a natural equivalence relation. Now we are going to show an example for how cosets forms an equivalence relation. Let us consider Z6 under addition modulo. Take us up here G be a group, that is Z comma plus circle, and H be a subgroup of G, which is nothing but the set of all 0, 3. Now we are going to compute all the left cosets and show how they forms an equivalent classes. So take a group Z6 which is equal to, that is integer modulo 6, so the set having an elements 0, 1, 2, 3, 4, 5. And the subgroup H consisting of an elements only 0 and 3. Now we compute all the left cosets of H in G. So take an element 0 plus H, which is equal to the set consisting of 0, 3. So 0 plus 0, 0 plus 3. It gives 0, 3. Similarly, next determine 1 plus H. That is 1 plus 0, 1 plus 3. That gives the value 1, 4. And next we have to take an element 2 plus H, which is equal to 2 plus 0, 2 plus 3, which is equal to the set consisting of an element 2, 5. So the left coset of 0 plus H is the set 0, 3. The left coset of 1 plus H is the set 1, 4. The left coset of 2 plus H equal to the set consisting of an elements 2, 5. Similarly, we determine the remaining cosets 3 plus H, 4 plus H and 5 plus H. 3 plus H gives the same value of 0 plus H, 4 plus H gives 1 plus H, 5 plus H gives the same value of 2 plus H. So the distinct left cosets of the group is Z6, which is nothing but the set of all 0, 3 and 1, 4 and 2, 5. So Z6 equal to the set of all only the distinct left cosets 0 plus H, 1 plus H, 2 plus H. Next we have to show all these left cosets, which is nothing but equivalent classes. So we already know the definition of equivalent congruence mod H, that is A congruent to B mod H if AB inverse belongs to H, which is equivalent to AH equal to BH. So to find the equivalent classes of the group, you have to find all the elements of B belongs to G such that A minus B belongs to the subgroup H consisting of an element 0, 3 mod 6. Here let us take the value of A equal to 1. So 1 minus 1 equal to 0, that belongs to H. 1 minus 4, which is equal to minus 3 congruent to 3 mod H. So you have to substitute the value for any value of B that takes from G. Anyway, that gives the value of the subgroup H equal to 0, 3. So here equivalent class of 1 is the set of all 1, 4. Take an element A equal to 2. So simply substitute any value of B from G, it gives the value of the subgroups 0, 3. 2 minus 2 gives the value 0, that belongs to H. 2 minus 5 which is equal to minus 3 congruent to 3 belongs to H. So the equivalent class of 2 equal to 2 comma 5. Similarly, the equivalent class of A equal to, take A equal to 0. So the equivalent class of 0 gives the value of 0 comma 3. Let us define the remaining equivalent classes of 3, 4 and H. Equivalent class of 0 which is also equal to equivalent class of 3, and an equivalent class of 1 which is equal to equivalent class of 4, and equivalent class of 2 which is equal to equivalent class of 5. So the distinct equivalent classes are the set consisting of 0 comma 3, 1 comma 4 and 2 comma 5. So the equivalent classes of the group Z6 which is equal to equivalent class of 0, equivalent class of 1 and equivalent class of 2. From this what we conclude that means the group Z6 which is equal to, that forms a distinct equivalent classes that also have the same left cosets. So Z6 which is nothing but the set of 0 plus H, comma 1 plus H, comma 2 plus H, which is also equal to equivalent class of 0, equivalent class of 1 and equivalent class of 2. So from this we summarize that all the left or right cosets forms an equivalent classes, that is HA equal to A, equivalent class of A. Thank you.